All right, you guys, so welcome to lesson 8.2 for Math 20-2. We're looking at solving problems that involve rates. So in the previous lesson, we were kind of having a little bit of an introduction to comparing and interpreting rates, and we're just going to basically expand on that a little bit in this lesson. So essentially we're going to do some more practice that kind of maybe takes some of the questions we looked at in the previous lesson a little bit further. So mostly basically today is just going to be examples because we're essentially just building on our skills with working with rates. So our first example has someone who's planning a trip to the United Kingdom. She needs to have British pounds when she lands there, so she needs to figure out how many pounds she will have if she exchanges $1,000 Canadian. The current exchange rate is $1 Canadian for every 0.63 Great Britain pounds. How many pounds will Marie get if she exchanges $1,000 Canadian? So generally what we're looking at when we're doing this kind of work is figuring out what our known ratio is. And actually we're given a ratio here as well. Actually, sorry you guys, I should have actually written down the known rate, because if you remember last time we actually talked about the fact that a ratio is comparing the same units, and we're actually looking at two different units, Canadian dollars and pounds. So our known rate right now is that for every $1 Canadian, oops, I forgot to put in the 1. Okay, so for every $1 Canadian, you're going to get, I'm not even going to try to draw the little pound thing, but you're going to get 0.63 Great Britain pounds. Okay. And what we want to figure out is if she has 1,000 Canadian dollars. And so what we want to do whenever we're trying to solve for an unknown amount, because we're going to figure out how many Great Britain pounds for a different amount of Canadian dollars, what we want to do when we're making these rates is we want to make sure that we have them kind of set up the same. So if I had $1 Canadian set up here, then I want to have my 1,000 Canadian on the top as well. So 1,000 Canadian is going to be on the top as well. And because our rates are essentially going to be comparisons with each other, that means I'm trying to solve for X Great Britain pounds on the bottom, just the way we have the comparison set up over here, Canadians to Great Britain pounds. The next thing we want to do is try and make these things equal. So if you remember in our last lesson we talked about using proportion to solve these types of problems. So essentially what we would have is 1 Canadian dollar for every 0.63 Great Britain pounds is equal to 1,000 Canadian. Okay, and so now because we've set them equal to, it means that we want to figure out if we want to go from 1 Canadian dollar to 1,000 Canadian dollars, what do we have to do? Now the important thing here is to always remember we never use, if we're comparing like fractions or ratios or rates, I guess would be the better word, we never want to use adding or subtracting, only multiplying or dividing. So if we want to get from 1 Canadian dollar to 1,000 Canadian dollars by multiplying or dividing, we would want to do it by multiplying by 1,000, right? So never like adding 999. So if I multiply this by 1,000, then in order to keep these two rates equal, I have to do the same thing to the bottom. So I would have to do 0.63 times by 1,000, right? So essentially I can go, this would be times by 1,000. Okay, and as we all know from years and years of doing math, the rule is always that if you do one thing to a fraction, like to the top, for example, then you have to do the same thing to the bottom. So times by 1,000 is going to give us 630 Great Britain pounds. Okay, And so that's one way of solving it. Now, if you do remember, I did also mention you can use cross multiplication. So in that case, we would have looked at the way we had our ratio set up here. And remember, you would want to multiply whatever two numbers are diagonal from each other. So in this case, that would be 0.63 times by 1,000, which is basically what we just did. And then divide by whatever number is left over. So the only remaining number value is 1. And when you divide by 1, that doesn't make a difference to the number. So you still end up with 630 Great Britain pounds. Okay, so now we can write down that. Marie will get 630 Great Britain pounds for 1,000 Canadian dollars. Okay, so that's our final answer there. All right, let's look at another example here. During her trip, Jody has the chance to go to France and visit the Juno Memorial. She knows that she will want a souvenir. Oops, a little typo there. So she wants to change some of her pounds into euros. She decides to exchange 120 pounds to euros because she has to buy lunch and snacks and, maybe some other things as well. How many euros will she have if the exchange rate is 1 Great Britain pound for every 1.13 euros? Okay, so again, we can kind of think about this. She has 1 Great Britain pound for every 1.13 euros. So you can see that these are going to be pretty similar, right? We're at 1 to just a little bit over 1. So we're not going to expect a huge change in the amount. But what we want to do when we do this solution is, remember, we want to keep our units the same. So if we had Great Britain pounds on top here, we want to have the Great Britain pounds on top here, and that was the amount that she had here. So you might just want to kind of do a little bit of highlighting here to kind of keep track of where everything was, right? So we had 120 pounds is what she came in with, and this was our exchange rate that we used. Okay. So she has 120 Great Britain pounds, and we want to solve for how many euros does she have? Euros. So again, this one is pretty straightforward, right? If we have it set up like this, 1 Great Britain pound, how do we make it into 120 Great Britain pounds? Remember, we can only use multiplication or division. If we want to make 1 into 120, we do that by just multiplying it by 120, which means that we would also do the same thing by the bottom, multiply by 120, and so 1.13 euros times by 120 gives us 135.60 euros. And you should always, if you're doing questions like this, you should always just stop and think if it makes sense. So if you get a little bit more than 1 euro for every 1 Great Britain pound, then you should have a little bit more than 120 euros instead of Great Britain pounds, right? And that's exactly what we see here. So because the answer makes sense, we can go ahead with that. So we would say Marie will have 135.60 euros for 120 Great Britain pounds. Okay. So it looks like she's going to get some pricey souvenirs or lunch. All right. Let's try another one here. So Danny is trying to figure out the best place to buy his gas. Let's see. He lives in the country, so his local gas station is selling gas for $1.09 per liter. If he drives into the city 10 kilometers away, he can get his gas for $1.07 per liter. His car consumes gas at a rate of 9 cents per kilometer. So if he's buying 60 liters of gas, where is the best place to get gas with regards to cost? Okay, so we're not thinking about, we don't want to give an answer like best to buy it in the country so he doesn't have to drive, even though that probably is better. But let's have a look just at the cost aspect here. So we want to think about ratios here, right? We want to think about we know what his cost is for each area per liter, but we want to know what it would be for 60 liters. Now, for some of you guys, you might feel like this is pretty obvious that you actually don't really need to set up equivalent rates, because if you have your price per liter and you're getting a certain amount of liters, you might know that it's always just going to be a multiple already, right? But just for the sake of understanding rates, let's go with this. So we have $1.09 per 1 liter in the country, and he wants to have 60 liters. So essentially we're seeing what would be the cost. Okay, and again, you can probably tell pretty quickly here, if we want to go from 1 to 60, we need to multiply by 60, remembering never to add or subtract. And so essentially that means we have to do the same thing here. So 1.09 times by 60, which would give us X equals $65.40. Okay, again, always think if your answer makes sense, and because we have a little bit over $1 for every liter, we would expect to pay a little bit over $60 for 60 liters, right? Which is what we see here, so that seems accurate. The next question we have is in the city, so we have the same setup here, $1.07 for every 1 liter. So still, thinking back to what we just said there, we're still going to expect that it'll be a little bit over 60, but not quite as much as this one because the cost is less, right? So basically we're going to have X dollars for 60 liters, and we're going to do the same math here where we want to multiply by 60. Both of these. Okay, so in this case, X is going to be equal to 64.20, and that makes sense, right? Because it's a little bit less than this one because the cost is less. But with the city one, we did have to keep in mind that he has to drive to get there, right? And we know that his cost to drive is 9 cents per kilometer. So here we see that we have another rate. So it's going to be $0.09 per 1 kilometer. How far does he actually have to drive? Well, if the city is 10 kilometers away, keep in mind he has to drive there and back. So that's going to be 10 kilometers each way, which would be 20 kilometers total. So how much is that going to cost him? Well, again, we see this simple math here. If we're going from 1 to 20, we're going to multiply by 20. Okay, and so when we multiply 9 cents by 20, we end up with X is equal to $1.80. And so what we need to do here is make sure that we have the total cost for getting gas in the city, which is the cost of the gas plus the cost to drive. And so we're going to say that it is $64.20 for the gas plus $1.80 for the drive, which is going to give us a total cost of $66. And so in the end, it does end up being a little bit cheaper to be to keep getting your gas in the country. Obviously, there's other factors that might make you not really care about those 60 cents, like if you want to get into the city and do something. But if we're just looking at cost, it is cheaper to to buy gas in the city, or I mean, sorry, in the country. Okay. So that's the bigger deal. All right, last question here. So Jason is buying a turkey for his family dinner. He has figured out that if he buys a turkey based on ½ a pound per person, the amount of turkey seems just right. This holiday he has 18 people coming to dinner. How large a turkey in kilograms does he have to buy? If the turkey costs $5.98 per kilogram, how much will the turkey cost? So, first of all, we're told the amount of turkey that he wants per person in pounds. And if you remember from our last lesson, we always want to make sure that we have our amounts correct. We know that there's 18 people going to be there. And we want to know how large of the turkey in kilograms. Okay. Because we are given the cost in kilograms. So that's probably why he wants to do the conversion. So those are our pieces of information. Now you are also given the conversion here. If you are asked a question like this on a test, I will always give you the conversion. You don't need to have those memorized. So we're told that 1 kilogram is equal to 2.2 pounds. So let's first of all figure out what the weight of the weight that he's looking for would be in kilograms, okay? And then we can start to figure out how much the turkey would be. So, I mean, alternatively, you could do, you could figure out if there's a ½ pound per person and there's 18 people, that's going to be 9 pounds. So if you wanted to, you could do 9 pounds and convert it into kilograms, but I just think it's easier to do the conversion when you have a 1 ratio, because that makes it easy to do the multiplication like we've done here, right? Because you know you just multiply it by the number you're trying to get. So usually that's a little bit easier, but of course it's not necessarily the only right way. So our ratio here is 1 kilogram for every 2.2 pounds. Sorry guys, I keep saying ratio and I mean rate. So 1 kilogram for every 2.2 pounds. We want to know, let's see, how large in kilograms. So we're looking for X kilograms. If we have, right, if we have a ½ a pound per person, so 0.5 pounds. Sorry guys, I got myself mixed up there by thinking about what I said earlier about the 1. Although, actually this is going to end up being, because the 1 kilogram isn't our exchange here, so it's not necessarily going to be easier than doing it the other way around, like I mentioned. So what happens here is, if we don't have a direct conversion, like if you can't just be like, you know, the way we've done here, where it would be like, well, of course we have to multiply by 20. 2.2 doesn't really have a clear thing to multiply it by to make it into a half. And so in that case, what you might want to do, or what you'll want to do, is a division. I just need to find my calculator here a second. Oops. Okay, so let me just have a quick look here. So basically what I did is, sorry, this calculator won't clear off. Okay, so basically if you go, I'm not sure if this is going to show up super well here, but essentially if you go, you take the units you're trying to go to and divide by the units that you came from. So essentially what this is going to tell you is 0.5 needs to be multiplied by 0.227 repeating in order to get 2.2, or sorry, in order to get 2.2 needs to be multiplied by 0.22 and then 727 repeating in order to get 0.5. Okay, so you take your number that you're looking for and divide it by the first one to figure out what the ratio is. And if you're not sure, so basically we're going to do multiplied by 0.2. I'm just going to draw a dot, dot, dot there. If you're not sure, you can always double check 2.2 times by this value. Gives us 0.5, right? So now we know for sure that that's the ratio. So then that means all we would have to do here is say 1 multiplied by the same value, 0.22. I'm just going to draw a dot dot, but when you guys are doing these calculations, make sure that you use the full value here so that you get the most accurate number possible. Okay, so we're going to do 1 times by 0.22, which obviously is just going to be the same thing. So now we can say we're going to have x equals 0.227 kilograms per person. Okay, so now that we know how much weight there is per person, 0.227 kg for every one person, we can say how many kilograms do we want if we have, right, we're keeping the same kind of a ratio here or rate. How many kilograms do we want for 18 people? And this one is going to be a nice and easy one because we can say that we're starting with a rate of 1 there. So if we go across, it's going to be obviously times by 18. So same thing up here. Okay. And 0.227, again, I kind of gave the rounded off number here, but I'm going to keep this whole number, times by 18, gives me 4.09 kilograms. Total is what we need. Okay, so that's answering the question of how large of a turkey in kilograms does he have to buy. Now we want to know the turkey costs $5.98 per kilogram. That's our rate, so we can fill that in here. $5.98 per 1 kilogram. We want to know how much is it going to cost. So basically we're looking for the top value here, which is X dollars, for the total mass of the turkey, which is 4.09 kilograms. And so, again, we can see here, if we want to go from 1 to 4.09, we just multiplied by 4.09. And that means we have to do the same thing for the top. 4.09. Okay, so we're going to do 5.98 times by, again, I'm going to keep the full number value there so that I'm as accurate as possible. So 24.46. And now, because I'm in my final answer, I can round it off. $24.46, right? So just using the same number of decimal points as you would find in dollars and cents, obviously. Okay, so that's everything for today. Bit of just, you know, an expansion on what we did yesterday. You guys have some assignment questions to try from the textbook, so you can go ahead and work on that. And yeah, I'll see you next class for lesson 8.3 when we start to look at, I believe it's comparing figures, like scale figures. So I will see you then.